Hello guys, this is the fourth video about the spine module, and on top of that I also changed my mic, so I hope that there will be less noise. I never anticipated for people to actually watch the videos, but it turns out that some people are watching it, and one of the feedback was like, please change your mic. Fair enough. It was a very cheap webcam microphone that I was using. Now I have hopefully a better one. I'm sorry for the previous quality of audios. What we saw last time is a little demo of the final setup, which will happen once I reconnect these nodes. And what we saw last time is, the implementation of the spline IK. Now, yesterday, in the previous video, I left out something on purpose in terms of features, and the reason why I left it out is because it allows me to show a way, to use these videos in order to build up additional feature by keeping the features atomic per se. In the video number 6, I think, I go through something called solver spline IK, which is this graph here, where I simply talk about the spline, which is very similar to this setup, the orange one, right? It's pretty much the same, it's just horizontal. In this setup here, if you go back to the video, you can see that I am doing different experimentation in order to trigger certain functionalities. One of it is the twist. And if we see here, the twist is currently missing. What is the twist? What I mean by twist? The twist is the idea that when you want to propagate the rotation that is happening between this control and this controls along the spine. So I'm hoping that by showing you this, I'm trying to demonstrate why I'm building up the videos in a certain way. Is this all of these are atomic functions that you can go back and study and watch every time you need to add a specific feature. That's why I subdivided them into solvers, which are atomic functions, and modules. So right now, if I rotate this, you can see that nothing is happening on the spine, and this is a little bit unrealistic. The spine is totally able to twist. So if we were to add the twist, how would we do that? If we jump into the spline IK module, yesterday this was the graph, okay? So this one here, I'm not going to go through it again. And if we have a look here not in the setup event is fine, but at the very end of the forward solve, which is here, let me comment that, setup event. If you're not in the setup event, at the very end there is the actual solver where we are attaching the controls to generate a curve to this node, which generates a curve which drives the bones. If you go back to this example here, which again I think is video number 6, you can see that I am doing I'm implementing the IK spline solver. So this graph is very similar to this graph. It's the same. And then I'm implementing the twist. And in that video I go through the concept of checking all the time what the order of operation is happening. It's providing. So this will give us a specific result. So first we do this one, so the solving for the IK spline, and then we do the solving for the twist. Then I actually say most of the time the effect that you get out of this is not what you want when you start thinking about IK spline and twisting. So what I do there is that I swap the two graphs. So first the blue one, the twist, and then the fit chain. Okay, so this graph here is this one, and this graph here is this one. And this, if I compile this now and check, this is basically the behavior that I'm looking for. When I twist, the rotation is distributed along the chain. Okay. So if I go back to the spine module, and I take and I keep in mind this graph, this portion of the graph here, it's the one with the fit chain. So the only thing I need to do is move this around, take this graph and copy it, which I already done. There it is. It's the same, trust me. I just made it prettier. It is exactly the same. Four controls, interpolation in quaternion, and then set rotation. So if I move this here now, and I connect the things, I want the for loop to complete and go into here, and I want this guy to go into here. So I comment the twist contribution, compile. Now you can see that the spine is twisting. Okay, and again, this is one of the example where I'm trying to justify the way I am slowly building up solvers, because if you try to make everything all at once, things get really confusing. Instead, if you work on a control rig allows you to layer stuff together really nicely. So if you work on a single effect and then store that effect somewhere, and then you can always go back and copy things, that's really nice. So so this is truly it for the spline AK. So today we're going to finally look at the module spine. So the module spine is the highest level for everything that is related to the spine. And of course, as you can imagine, there is a setup mode and non-setup mode. So let's start by detaching only the spline IK solver, but rather attaching the module spine. In the setup event, the module spine is been set to be in setup mode, and then you can literally duplicate this node and turn off setup, and it would still be the same. Okay. By default, only the FK controls are turned off, but you can change this. Okay. So this is it. How does the spine module works? The spine module takes a bit of inputs, and I do realize that the amount of inputs in the nodes that I'm building is quite high. Although right now we are gonna keep manually editing the names when we're gonna have to adapt this rig to another configuration of bones and geometry. But later on, once we are kind of finished with the bipedal structure of a control rig, then we're gonna start moving into how to create a proper template, so we don't have to go through the painful process of renaming things. So for now we will have to stick with this. Then we're going to start talking about struct, which is it's a data structure in Unreal that allows you to encapsulate different variables with different types. But don't worry about that for now. So okay, the module spine, the input is we have the bones. I want to know what the pelvis is, the spine bone is, rib cage bones, and where it ends. And the same for the controls. Give me the controls. Give me the controls for the tangency. Give me the rib cage IK control. Give me the full body control. Give me the FK controls. And then in here, just give me the option to set the visibility of which structure. This is not truly necessary. This is just me trying to make a nice, good-looking, clean rig in terms of visibility. So the animator has fewer and fewer controls at the beginning, and only when it needs them it can turn them on. It's just to keep the the complexity, the visual complexity of the rig simple. So the first thing I do here is I'm checking the visibility. I'm checking this attribute. Based on this attribute, I'm either hiding, if I trouble here, this visibility hides or unhides depending on this control, everything that is FK. So I'm taking the start position, the start control, the start control of the control, the start control, and the end control that everything that is FK. I am taking all the controls in between. I'm storing them into a collection, and then for each item of the collection, I set the visibility based on this attribute. Same goes for, let me see, this, for the secondary control visibility. The secondary control visibility was the rib cage here and the tangent control for the IK spline, and then the actually IK controls. Okay, so this is nothing else than setting visibility. After that, I go through a sequence, and this is mostly for organization and to keep the return node of the function always clean at the very end. So in the first thing I do, am I in setup mode? Yes, I'm setup mode. So the first part of the spine module is, because this is not really necessary, this is just cosmetics, you know, and functionalities. The first part that I'm doing is procedurally place the body control between spine and pelvis bone. What I'm taking here is basically this get transform bone represents the pelvis, and this get transform bone represent the first spine bone. So this is spinal 1. If you were to look where this is going, is literally spine 1 and pelvis. Then I'm interpolating between the two, and I'm setting the value of the interpolation to be 0.5. So what I get is the pivot exactly in the middle. Okay? And then what I do is I set the control offset of this control. So this control has a world position of a certain values and a local position of 0. This is just precision values, nothing to worry about. And then you may notice that I'm only setting the translation. Yes, I don't want to have any orientation of this guy, and we discussed this a lot. In biped specifically, I want this control to always be nice and flat and oriented like the world. So my values are extremely clean when it comes to animating them. Up and down means up and down in a world kind space position rather than local to the spine. If you want this control to be oriented, like if this is an extremely curvy, I don't know, curvy character, and you want the body to be oriented, you would plug everything, not just the translation. The second, really annoying capital L. So, really? I need to change the letter and then you change it back. Okay. The second thing I'm doing is procedurally placing the FK controls based on bones, and we have done this many times. So I'm taking what I'm doing here. These two item chain are give me the first spine bone, give me the last spine bone, which is the bone that represent the rib cage, give me the first control and the last control, and snap them together in a loop. So for each bone, give me its transformation, and for each control, set its transformation based on the current selected bone. So what happens is that each of these yellow circles gets snapped automatically to this bone. Cool. And as you can see, I'm doing translation as well. The third thing is I'm running solver spline IK, which we should be really familiar, into this. Let me toggle that. In setup mode. So what I'm doing is we discussed this yesterday in the previous video, but I'm procedurally placing the controls. And let me turn on the visibility of the IK controls. I'm procedurally placing the controls, this one, and the one in the middle, based on certain rules that we discussed yesterday. And this is the way I did it is just by simply taking the solver spline IK, hooking up the things, and then run saying this node runs in setup mode. It's literally like every other solver we made. This is the bit that it's something I want to focus a bit more. So yesterday I went on and on about something. Let me hide the IK. I want this to be as clear as I can. Yesterday I went on and on talking about flexion and extension, and when it comes to the spine, and then when it comes to a limb, the anatomical words are supination and pronation. it's something that it's worth learning in comparative anatomy or in anatomy in general. So I went on and on and on by saying positive values, negative values, C shapes, U shape. Positive values are flexion, negative values are extensions. How do we define flexion? How do we define extension? Etc. 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 Here's where I am orienting the pelvis. I'm snapping the pelvis to the bone that I want, and I'm flipping the quaternion by two axes, and the reason is let's not do that. Let's not do it. Finally, we should be able to see. So you can see that when I take this control, all right. If I don't set this thing, when I take this, let's say I moved. Let's have a look at this control here. These four controls. Let me move them backwards. You can see that now we are on minus 17, right? Something like that. No, minus 24. Minus 20. Let's put it minus 20 precise. So minus 20 definitely represents an extension. Okay? And I was able to move all these controls all together, and they all moved towards that direction. Now let's put this guy to minus 20. You can see that it's going forward. So if I were to reset this animation and select all of them now, and try to do what I was doing before, remember C shape, reverse C shape, this is what it would happen. You can see that the axis, although the rig is doing what we're telling it to do, so, but when the spine moves forward, 99% of the time, the pelvis rotate forward to accommodate the position of the hips and the knee. Okay, so if we were to do that and leave it like that, the animator would have to take this and check the value and flip it in the curve, in the animation graph. So instead, by flipping the orientation of the axis, and what I mean by that, I'll show you in a second. If I were to look at the orientation of these controls, you can see that Z is up, Z is up, Z is up, and Z is up, and on the pelvis, Z is up as well. I wanna preserve the Z. This is how you read it, but flip on the other two axes. Let's do that. You can see that Z is still up, but the rotation around the control, around the transform, gets flipped. Okay, so now if I rotate again, this is what I get: consistent behavior and values. I hope this clarified what I was talking about yesterday. I left this here just for as a reminder. And then I'm procedurally placing the rib cage control. And the rib cage control is nothing else than the circle. And let me hide that. Is this one. So this control here is its pivot. It gets snapped to this position. The reason why is visually offset it is because I offset the location of just the gizmo. This thing here only manipulates the shape, right? It has nothing to do with the transfer. This simply shift the position. I lost it. Simply shift the position of this object. How was it? Not 0. And this was up that way. Yeah. It simply shift the shape, the circle, not its transform. So when I rotate this, it still rotates from this pivot, and this allows you to position controls. Because imagine that there is a guy here that is really muscular. If you were to leave the control at the very center, you were not able to pick it, so you can move it outside. Okay, so we're done. We have all the controls, IK controls, FK controls, and everything, and all the extra controls placed. That's great. The second thing I'm doing is not being in setup mode anymore. So the first thing I do is I run the spline AK solver. That's easy. I just drag and drop the spline AK solver and connect the bones. Right in the input. Yeah, start bone, end bone, start control, end control, tangent control, and duration, but not in setup bone. So boom, at this point, at this very point of the graph, I have those orange controls working. Then what I'm doing is I forgot what this is, bear with me. Oh yeah, here I'm actually connecting the pelvis. Yes, fair enough. So here I'm just simply saying this control here drives the pelvis bone, and the reason why I'm using a project to new parent is exactly because of this reason here. It's because this control is not aligned to the bone. I cannot use a direct connection. I need to project it into a new space. So it's basically a parent constraint of this object to this bone. So now I can get this behavior here. Then what I'm doing here, I think this probably is the rib cage. Yes, this is the rib cage, and what I'm saying is that this control here drives the rib cage bone with the transform. Okay, and again, because this control here is specifically oriented, I'm using project to new parent. The last thing I'm doing is distributing the rotation of this joint, of this control here, along the chain. Which chain? The rib cage and the end rib cage. The reason why I'm doing this way, we're gonna see in a minute, because I'm gonna swap skeletons now, is so I can travel from here to here and check all the joints and apply this rotation to all the joints. And this is meant to be kind of a secondary kind of thing, because most of the time this rib cage in blocking animation will perform rigidly. So once you're happy and you want to tweak your final silhouette, you can unhide this control and just adjust it. And that's it. That's pretty much it. That's the spine module. So now I got rid of the spline AK, and now it's just a matter of filling up the bones. We have the pelvis, the spine, the rib cage bone is where the rib cage ends, etc., etc. Now, to be a little bit more to keep this discussing this, I'm gonna try to do something. Jump into spine 2, and let's see. Oh yes, there it is. In Maya, I've prepared, it's the same exact thing, but now I have more joints here. And as we discussed, this might be an option for you when it comes to cartoony characters. So this setup here allows us to have a very rigid spine, implement all the features that we've done so far, but also having a little bit more control over the silhouette of the upper part of the body. So if I were to select all these bones here and rotate it, you can see that I can get really extremely advanced, no, I wouldn't say advanced, extremely flexible spine. And this might be necessary for something like it's a super cartoony character, or a squashy stretchy character, or a Spider-Man that needs to just bend that way, you know. Anatomically this is not really correct, but hey, sometimes we have to do, you know, non-anatomically correct characters. As a suggestion, when you build up your stuff, and this is just by coming from experience, even if it's a cartoon character, always fall back to anatomy by default. It will give more believable deformation. This is just a hint. It's just a suggestion. So okay, so I brought in that character over there. I brought it in, and you can see that this is the hierarchy. Great. So what I need to do here is, let me turn off autocompile for a minute and let me delete this thing. So I have no skeleton now, and I want to import many joint. I call it many joints. Let me save this as well. let me import it. I'm not sure where I left it, to be honest. Cool. Okay, so I want to import hierarchy. I'm going to type here many joints. Great. So I have this thing. I want to have many joints here as a preview mesh, and then because the bones disappear, I'm going to have to reload. Great, now we have everything. So yes, the position of the controls doesn't have to change because this is pretty much the same thing, but there is one thing that we need to change. So before changing it, our insertion for the neck or clavicles here was called spine 6, and that's where ribcage end bone is. But now I'm added more, so it's spine 10. So here I just need to change to spine 10 in the setup, and in the forward sole spine 10. And I think that's pretty much it, because that's the only thing I changed. Now keep in mind, when you do a setup like this, I said this in the first video, but you need to be careful to always have a bone that identifies the rib cage. Otherwise, you will start getting weird deformations and weird pivoting. So in my case, spine 4 has always been my go-to for the deformation of the spine. Okay, so I don't have to change it. I simply added more joints above. Let's see what happens when I compile. So in theory, everything should still work, and it does. We have spine IK, we have this. But now, if I were to rotate here, because I'm using a procedural approach to know which bones from here to here, when I rotate that, you can see that the bones are actually, it doesn't matter how many bones are inside. Before we had 2 or 3, and now we have 6, and it still works. So what this gives us is, the ability to create this shape, which is, let's say, anatomically correct, and then break out from that and even create, a very interesting, flexible spine. So this will be it for the module of the spine. I hope you guys found this interesting. The next thing that I'm going to do is do a little bit of unit testing in the next video, where I'm going to apply this setup to test if it works with any character from any skeleton. The same thing we did for the arms and legs. So I guess I'm going to use the Mixamo one. Thank you.